In the early universe, there should have been nothing. No giant galaxies, no massive structures, no cosmic cities filled with billions of stars. The universe was simply too young. According to everything we know about cosmology, galaxies need time to form, hundreds of millions, sometimes billions of years. Gravity slowly pulls matter together, gas collapses, stars ignite, and over immense stretches of time, galaxies are born. But recently, astronomers pointed one of the most powerful telescopes ever built toward the distant universe. And what they found didn't make sense. A galaxy so massive, so bright, and so developed that it simply shouldn't exist yet. It appeared at a time when the universe was still in its infancy, only a few 100 million years after the Big Bang. Too early, far too early, which raises a terrifying possibility for cosmology. What if our understanding of how galaxies form is wrong? What if the early universe was far more complex than we ever imagined? Tonight, we explore one of the strangest discoveries in modern astronomy. A galaxy that appeared too soon. A galaxy that shouldn't be there at all. The early universe was supposed to be empty. To understand why this discovery is so strange, we need to go back to the beginning, not billions of years after the Big Bang, but just a few 100 million years after it. In cosmic terms, that's almost nothing. The universe today is about 13.8 billion years old. But the galaxy we're talking about appeared when the universe was only around 300 to 500 million years old, less than 4% of its current age. At that time, the universe was still young, very young. There were no mature galaxies, no massive structures, no cosmic systems like the ones we see today. Instead, the universe was in a stage astronomers call the cosmic dawn, a period when the first stars were just beginning to ignite. Before that moment, the universe had gone through something called the Dark Ages. After the Big Bang, the universe expanded and cooled. Atoms formed, mostly hydrogen and helium. But there were no stars yet, no galaxies, just an enormous dark ocean of gas stretching across space. Gravity was slowly working, pulling matter together. But this process takes time. A lot of time. Clouds of gas have to collapse. Small clumps of matter must merge into larger ones. Stars must form. Those stars must live, die, and release heavier elements. And only then can galaxies begin to grow into large, complex structures. This is why astronomers always believed that large galaxies could not exist in the very early universe. The timeline simply doesn't allow it. It takes hundreds of millions of years just to form the first stars, and far longer to build entire galaxies containing billions of them. That's the standard model. And for decades, every observation supported it. Until recently, because when scientists began looking deeper into space than ever before, they started seeing something unexpected, objects that looked far too large, far too bright, far too developed, galaxies that appeared to exist much earlier than they should. And this creates a major problem, because when we look into deep space, we are actually looking back in time. Light from distant galaxies takes billions of years to reach us, which means when we see them as they were in the distant past. So when astronomers detect a galaxy extremely far away, they are seeing it when the universe was still very young. And what they expected to see was something small, primitive. Early galaxies should be messy collections of young stars, still forming, still growing. But instead, some of them appear massive, structured, almost mature, as if they had already been evolving for a very long time, which leads to a disturbing possibility. What if galaxies in the early universe formed much faster than our models predict? Or even worse, what if our understanding of the early universe is incomplete? Because if galaxies could grow this big, this fast, then something fundamental about cosmology might be missing, and that is exactly what astronomers began to suspect, especially after one telescope started revealing the universe in a way we had never seen before. A telescope designed to look deeper into cosmic history than any instrument before it. A machine capable of seeing the very first galaxies ever formed. And when it finally opened its eyes to the universe, the discoveries it made were not what scientists expected. Instead of confirming our theories, it began to challenge them. And among those discoveries was one object that stood out above all the others, a galaxy so massive, so bright, and so early in the history of the universe that it simply should not exist. The telescope that looked too far. For decades, astronomers have tried to answer one simple question. What did the first galaxies look like? To do that, scientists needed a telescope capable of looking farther back in time than ever before. Because the farther we look into space, the further into the past we see. Light takes time to travel. When we observe distant galaxies, we are seeing them not as they are today, but as they were billions of years ago. This is why deep space is often described as a cosmic time machine. And to explore the earliest chapters of the universe, scientists built the most powerful space telescope ever launched, the James Webb Space Telescope. Unlike previous telescopes, this one was designed specifically to study the early universe. Its enormous mirror collects faint light from extremely distant objects, and its instruments are tuned to detect infrared light. This is crucial, because as the universe expands, light from distant galaxies stretches. What once began as visible light becomes infrared by the time it reaches us. This effect is called cosmic redshift. The older and more distant the object, the more its light shifts toward the infrared part of the spectrum. And this is exactly where the James Webb Telescope excels. It can see galaxies that formed just a few 100 million years after the Big Bang, something no telescope before it could do with this level of clarity. When the first images from Webb were released, astronomers were excited. They expected to see tiny, faint galaxies, small structures just beginning to form, the earliest building blocks of the universe. But almost immediately, something strange appeared. Some of the galaxies Webb detected were far brighter than expected, not just slightly brighter, but dramatically brighter. Brightness in astronomy usually means one thing: mass. A brighter galaxy typically contains more stars, which means it must have formed a large amount of matter into stars very quickly. But according to current cosmological models, that shouldn't happen so early. In the first few 100 million years after the Big Bang, there simply hasn't been enough time. Gravity needs time to gather matter. Gas needs time to collapse. Stars need time to form. And galaxies need time to grow through mergers and accumulation. Yet Webb was seeing objects that looked far too mature. Galaxies that seemed fully formed. Galaxies that should have needed billions of years to reach that size, but somehow existed when the universe was still an infant. Among these discoveries were candidates like Glass-Z13 and Sears-93316. These galaxies appear at redshifts so extreme that they may have formed only a few 100 million years after the Big Bang. And if those measurements are correct, then our current models of galaxy formation might be incomplete or even wrong. Some astronomers have proposed possible explanations. Maybe early star formation was far more efficient than we thought. Maybe galaxies in the early universe formed stars much faster. Or maybe these objects contain extremely bright population 3 stars, the first generation of stars ever formed. Stars that were far more massive and luminous than the stars we see today. But even these explanations struggle to fully account for what Webb is seeing, because the galaxies are not just bright. They appear large, structured, as if they had already undergone long periods of evolution, which should have been impossible at that time. And this is why the discovery is so unsettling, because astronomy depends on models that describe how the universe evolves. If galaxies can appear this large, this early, then something about those models is missing, something fundamental. Either the universe built galaxies far faster than we expected, or our understanding of cosmic history needs to be rewritten. And the deeper the James Webb Telescope looks into the early universe, the more mysteries it continues to reveal. A galaxy that formed too fast. When astronomers first began analyzing the strange galaxies discovered by the James Webb Space Telescope, one question immediately appeared. How did these galaxies grow so large so quickly? Because according to everything we know about the universe, building a galaxy takes time, a lot of time. First, dark matter begins the process. Invisible halos of dark matter form shortly after the Big Bang. These halos act like gravitational traps. They pull in gas, mostly hydrogen and helium. Over time, that gas collapses and forms stars. Small clusters of stars appear first. Then those clusters merge into small galaxies, and through billions of years of collisions and mergers, large galaxies are slowly built. This process is gradual, slow, messy, which is why scientists expected the earliest galaxies to be tiny, young, barely assembled. But the galaxies Webb detected don't look like that at all. Some of them appear to contain billions of stars. That means an enormous amount of gas must have collapsed and formed stars extremely quickly, much faster than our models predict. To understand how unusual that is, imagine trying to build an entire city overnight. Not a few houses, not a small village, but a massive city filled with skyscrapers, highways, and infrastructure. In reality, cities take decades or centuries to grow, yet these galaxies appear as if they were built almost instantly in cosmic terms. One possible explanation is that star formation in the early universe was extremely intense. The first stars may have formed inside very dense clouds of gas, and once star formation began, it may have spread rapidly throughout entire galaxies. But even then, there's another problem. Stars themselves take time to influence galaxy growth. When stars explode as supernovae, they spread heavy elements into space. These elements help cool gas clouds, making it easier for new stars to form. This feedback cycle normally takes millions of years, but the early galaxies Webb is seeing seem to have bypassed many of these slow steps, as if they skipped entire stages of development, which leads to a deeper mystery, because galaxies are not just collections of stars. They also depend on dark matter. Dark matter provides the gravitational framework that holds galaxies together. Without it, stars would simply drift apart. But if these galaxies are so massive so early, that means their dark matter halos must also have formed extremely quickly. faster than many cosmological simulations predicted. And that's where things start to get uncomfortable for scientists, because the standard model of cosmology, often called lambda CDM, has been extremely successful. It explains how the universe evolved from the Big Bang to the complex cosmic web we see today. It predicts how galaxies should form, how matter should cluster, how structures grow over time. But discoveries from the James Webb Telescope are beginning to test those predictions, not completely breaking them, but stretching them, pushing them into territory where the models start to struggle. Some astronomers believe the galaxies might only appear larger than they truly are. Perhaps bright young stars are making them seem more massive. Others think the distance measurements might still contain uncertainties. But if future observations confirm these galaxies are truly as large as they appear, then something about our understanding of galaxy formation may need to change, because the early universe might not have been as slow and simple as we once believed. It may have been far more dynamic, far more chaotic, a place where matter assembled faster, stars ignited sooner, and galaxies emerged long before we thought possible. And if that's true, then the universe may have started building its cosmic structures much earlier than we ever imagined. The first stars changed everything. Before galaxies could exist, something else had to appear first. The very first stars. Astronomers call them population 3 stars. They were unlike any stars we see today. To understand why, we have to remember what the universe looked like shortly after the Big Bang. Back then, the universe was extremely simple. It contained mostly hydrogen and helium, almost nothing else. Elements like carbon, oxygen, iron, and silicon didn't exist yet. Those heavier elements are created later inside stars. That means the first stars formed in a universe that was chemically primitive. And because of that, they behaved very differently. Modern stars, like our Sun, form from gas clouds that contain many heavy elements. These elements help gas cool efficiently. Cooling allows gas clouds to fragment into many smaller pieces. Each fragment can collapse into a star. But in the early universe, without those heavy elements, gas clouds couldn't cool as easily. Instead of breaking into many small stars, the clouds collapsed into fewer but much larger stars. Some scientists believe these first stars may have been hundreds of times more massive than our Sun. That makes them extremely powerful, extremely bright, and extremely short-lived. Massive stars burn their fuel incredibly fast. While our Sun will live for about 10 billion years, a giant population 3 star might survive only a few million years. But during that short lifetime, it releases enormous amounts of energy. These stars flood their surroundings with intense radiation. They ionize the gas around them, and eventually, they explode as incredibly powerful supernovae. When that happens, something important occurs. Heavy elements are created for the first time. Carbon, oxygen, iron, elements that did not exist before. These materials are blasted into surrounding space, enriching the gas clouds of the early universe. Now, future stars have access to heavier elements. This changes everything. Gas clouds can cool more efficiently. Star formation accelerates. New generations of stars begin forming more rapidly. And eventually, the first galaxies start to assemble. This process is believed to have triggered what astronomers call the cosmic dawn, a period when the universe transitioned from darkness to light. Before that moment, the universe had very few luminous objects. But once stars began forming in large numbers, the universe started to glow. The light from these stars slowly ionized the hydrogen gas that filled the cosmos. This era is known as the Epoch of Ionization, and it completely transformed the universe. Small clusters of stars merged together. Gas continued collapsing into dark matter halos, and gradually the first primitive galaxies emerged. According to current models, these early galaxies should have been small and chaotic, irregular collections of young stars still forming, not massive structures filled with billions of stars, which is exactly why the galaxies observed by the James Webb Space Telescope are so surprising, because they appear far more developed than expected. As if the early universe had already gone through multiple generations of star formation, as if galaxies had time to evolve. But according to our timeline, there shouldn't have been enough time for that, which raises another fascinating question. What if the first stars were even more powerful than we thought? What if early star formation was far more intense? Could those first generations of stars have accelerated galaxy formation, creating massive galaxies far earlier than predicted? Scientists are still searching for the answer. And as the James Webb Telescope continues scanning the early universe, it may soon reveal whether these mysterious galaxies are rare exceptions, or signs that the early universe evolved much faster than we ever imagined. The role of dark matter. To understand how galaxies form, we must talk about something we cannot see, something that does not emit light, something that does not reflect light, and yet it shapes the entire universe. This mysterious substance is called dark matter. Dark matter is one of the biggest puzzles in modern physics. Scientists cannot observe it directly, but they know it exists because of its gravitational effects. Galaxies rotate too fast to be held together by visible matter alone. Clusters of galaxies bend light from distant objects more than they should. Large cosmic structures appear, where gravity must have been stronger than visible matter can explain. All of this points to the same conclusion. Most of the matter in the universe is invisible. In fact, dark matter makes up about 85% of all matter in the cosmos, and without it, galaxies would never have formed. After the Big Bang, the universe began expanding rapidly. Matter spread out in all directions, but small density variations existed from the beginning. Tiny fluctuations where matter was slightly more concentrated. Dark matter responded to these fluctuations first. Because it interacts mainly through gravity, it began clumping together early in cosmic history. These clumps formed what scientists call dark matter halos. Imagine enormous invisible spheres of gravitational influence. Inside these halos, gravity becomes stronger. Gas begins to fall inward. Hydrogen and helium gather. Over time, these gas clouds collapse and form stars. And eventually, galaxies are born. So, in many ways, dark matter acts like the scaffolding of the universe. Visible galaxies form inside its invisible structure. But here's where the mystery deepens. If galaxies discovered by the James Webb Space Telescope are truly as massive as they appear, then their dark matter halos must also be enormous. And they must have formed incredibly early. Much earlier than many cosmological simulations predicted. This creates a challenge for our models. Because dark matter structures grow gradually. Small halos merge into larger ones. Large halos attract more matter, and galaxies slowly build up inside them. But if massive halos existed extremely early, then structure formation may have happened faster than expected. Some scientists think the early universe might have been more efficient at creating dark matter structures. Maybe dark matter clumped together more rapidly. Maybe the density fluctuations after the Big Bang were stronger than we thought. Or perhaps there are aspects of dark matter physics that we still don't fully understand. Because despite decades of research, we still do not know exactly what dark matter is made of. It could be exotic particles. It could be something entirely new in physics. And if its properties are slightly different from what current theories assume, that could change how quickly galaxies form. This is why the discovery of these early massive galaxies is so important. They don't just challenge our understanding of galaxy formation. They may also reveal something new about dark matter itself. If dark matter behaves differently than our models predict, then the entire timeline of cosmic structure formation might need revision, and that possibility excites scientists around the world, because sometimes the most puzzling discoveries lead to the greatest breakthroughs. A strange galaxy, appearing too early in cosmic history, maybe hinting at deeper secrets hidden within the universe. Secrets about the invisible matter that built the galaxies and ultimately shaped the cosmos we see today. The mystery of the early universe. The deeper astronomers look into space, the further back in time they travel. Every distant galaxy is a glimpse into the past, a snapshot of what the universe looked like long ago. And thanks to the James Webb Space Telescope, scientists can now observe galaxies that formed only a few 100 million years after the Big Bang. This period of time is incredibly important, because it marks the moment when the universe began transforming from a dark, empty place into a cosmos filled with stars and galaxies. Astronomers call this era the Cosmic Dawn. Before this time, the universe had very few luminous objects. Gas filled the vast emptiness of space, mostly hydrogen and helium left over from the Big Bang. Gravity slowly pulled this gas together. Tiny fluctuations in density gradually grew larger, and eventually, the first stars ignited. Those first stars were powerful, massive, brighter than almost anything we see today. But they were also rare. Early star formation was expected to be limited. Only small clusters of stars would appear at first. Small proto-galaxies would slowly grow through mergers. This slow growth is the foundation of our current cosmological models. But the galaxies discovered by jwst appear to break this rule. Some of them seem too bright, too massive, too organized, almost as if the universe skipped several steps in its development. Instead of starting small and gradually growing, these galaxies look like they appeared already fully developed. That is what makes them so mysterious, because the early universe simply wasn't supposed to be capable of building structures that quickly. To visualize the problem, imagine watching the construction of a city. Normally, the process begins with a few buildings. Then roads appear. Infrastructure grows. More buildings are added. Eventually, decades later, the city becomes large and complex. But what astronomers are seeing would be like discovering a massive modern city, already standing just days after construction began. The timeline doesn't make sense, and that forces scientists to ask difficult questions. Maybe early galaxies were not actually as massive as they appear. Perhaps the light we see is dominated by extremely bright young stars. Those stars could make the galaxy appear larger and more mature than it truly is. Another possibility involves dust. Dust inside galaxies can affect how we measure brightness and distance. If dust behaves differently in early galaxies, our estimates might be slightly distorted. But even with these possibilities, many researchers believe something deeper may be happening, because the more jwst observes the early universe, the more unusual galaxies it continues to find. Some appear extremely compact, others appear surprisingly large, and a few seem to contain enormous numbers of stars far earlier than expected. If these observations continue to be confirmed, they may reveal something important. The early universe may have been far more dynamic and chaotic than our current models suggest. Instead of a slow and steady process of galaxy formation, there may have been bursts of extremely rapid growth, periods when matter collapsed quickly, stars formed rapidly, and galaxies assembled faster than anyone predicted. This possibility is both exciting and unsettling, because if it's true, then our understanding of cosmic history may only be part of the story. The universe might be capable of building structures much faster than we ever imagined, and the mysterious galaxy that appeared too early may be one of the first clues that the early universe was far more active than we once believed. Could our cosmology be wrong? For nearly a century, astronomers have been building a model of how the universe works, a framework that explains how matter formed, how galaxies grew, and how the cosmos evolved after the Big Bang. Today, that framework is known as the Lambda CDM model. Lambda represents dark energy, the mysterious force causing the expansion of the universe to accelerate. CDM stands for cold, dark matter, the invisible matter that forms the gravitational skeleton of the cosmos. Together, these two ingredients describe a universe where structure forms gradually. First, tiny fluctuations in matter appear shortly after the Big Bang. Over millions of years, gravity amplifies those fluctuations. Dark matter gathers into halos. Gas falls into those halos. Stars form. Galaxies slowly emerge. Then those galaxies collide and merge, growing larger and more complex over billions of years. This model has been incredibly successful. It explains the large-scale structure of the universe. It predicts the distribution of galaxies. It matches observations of the cosmic microwave background. For decades, it has been one of the most accurate scientific models ever developed. But every model has limits, and sometimes new observations push those limits. That may be exactly what is happening now. Because the galaxies observed by the James Webb Space Telescope appear to challenge the expected timeline of galaxy formation. If these galaxies truly contain billions of stars only a few 100 million years after the Big Bang, then galaxies may have grown faster than Lambda CDM predicts. This does not necessarily mean the model is wrong, but it could mean something important is missing. Perhaps early star formation was far more efficient. Maybe gas clouds collapsed more rapidly in the young universe. Or perhaps dark matter behaved slightly differently during those early stages of cosmic history. Another possibility is that we are witnessing extremely rare objects. Outliers, galaxies that formed unusually quickly, but do not represent the typical universe. But if jwst continues discovering more galaxies like these, then scientists may have to reconsider some assumptions. Because cosmology depends heavily on simulations, researchers run massive computer simulations to recreate the evolution of the universe. These simulations use known physics to predict how galaxies should form. But if real observations start deviating from those predictions, then the simulations must be updated. And sometimes, small adjustments can have enormous consequences. A tiny change in early star formation rates could dramatically alter how quickly galaxies grow. A small difference in dark matter behavior could accelerate structure formation. Even subtle changes in the physics of gas cooling could reshape our understanding of early galaxy evolution. This is why discoveries like these are so important. They force scientists to test their theories, to refine their models, and sometimes to rethink the foundations of our understanding, because the universe does not care about our expectations. It follows its own rules, and occasionally it reveals something that surprises even the most experienced astronomers. The strange galaxies appearing in the early universe may be exactly that. A reminder that our knowledge of cosmic history is still incomplete, and that somewhere in the depths of space, the universe may still be hiding secrets we have yet to uncover. Seeing the universe's first cities, when astronomers look deep into space, they are not just searching for galaxies, they are searching for the first structures ever built in the universe, because galaxies are not random collections of stars. They are enormous systems containing billions, sometimes trillions of stars bound together by gravity. They are the cities of the cosmos, and every galaxy we see today has a history, a story that began shortly after the Big Bang. At first, the universe contained only simple ingredients: hydrogen gas, helium, and invisible halos of dark matter. Gravity slowly pulled these ingredients together. Tiny regions of slightly higher density grew larger over time. Dark matter formed the first gravitational wells. Gas began falling into those wells, and eventually, stars ignited. At first, these stars were scattered, small clusters, primitive structures. But as gravity continued working, these clusters merged together. Over millions of years, small proto-galaxies combined to form larger ones. This process is called hierarchical structure formation. It means the universe builds large structures from smaller ones, like villages merging into towns, towns merging into cities, and cities forming vast metropolitan regions. But here's the key point. This process normally takes an enormous amount of time. Hundreds of millions, sometimes billions of years, which is why astronomers expected the earliest galaxies to be small, chaotic, still in the early stages of growth. Yet some galaxies observed by the James Webb Space Telescope appear surprisingly large, large enough to contain billions of stars, large enough to resemble mature galaxies. And they exist at a time when the universe was still extremely young. To understand how strange that is, imagine looking back at the earliest human settlements. You would expect to see tiny villages, small communities just beginning to grow. But instead, imagine discovering a massive modern city already standing there. Skyscrapers, road networks, infrastructure already built. That would completely change our understanding of how civilizations developed. In a similar way, these early galaxies challenge the idea that cosmic structures grew slowly. Some of them appear to have formed remarkably quickly, which raises an intriguing possibility. Perhaps galaxy formation in the early universe was not always gradual. Perhaps there were periods when matter collapsed extremely rapidly. Moments when enormous amounts of gas fell into dark matter, halos, all at once, triggering bursts of star formation that built galaxies in a fraction of the expected time. These events are sometimes called starburst periods. During a starburst, galaxies produce stars at extraordinary rates, hundreds or even thousands of times faster than galaxies like the Milky Way. If early galaxies experienced powerful starbursts, they could grow much faster than we previously believed. but even that may not fully explain what jwst is observing, because the telescope continues to discover galaxies farther and farther back in time, closer to the very beginning of cosmic history. And each discovery pushes the limits of our understanding a little further. Each new galaxy becomes another piece of the puzzle, another clue about how the universe built its first cosmic cities. And as astronomers continue exploring these distant objects, they may soon learn whether these strange galaxies are rare exceptions, or the first signs that the early universe was capable of building enormous structures far sooner than anyone expected. The galaxies that should not exist. As the James Webb Space Telescope continued scanning deeper into the universe, astronomers expected to confirm what previous telescopes had already suggested, that the earliest galaxies were small, faint, and primitive. But instead, something surprising kept appearing in the data. Galaxies that seemed far too bright, far too massive, and far too organized for the early universe. Some of these galaxies appear only a few 100 million years after the Big Bang. At that time, the universe should still have been in the early stages of structure formation. Stars were only beginning to appear. Small clusters were forming. Galaxies should have been tiny and chaotic. But the objects jwst discovered do not always match that picture. Instead, some of them look like fully formed galaxies, structures that may contain billions of stars. In cosmic terms, that is enormous. To understand how strange this is, imagine building a forest. First, you plant a few seeds. Small plants appear. Then, over decades, trees grow. Eventually, after many years, the forest becomes dense and mature. But what astronomers are seeing would be like discovering a fully grown forest just days after planting the seeds. The timeline simply doesn't match. One of the most intriguing examples is the galaxy candidate Z13. If its distance measurements are correct, this galaxy may have existed when the universe was only about 300 million years old. That is extremely early in cosmic history, and yet it appears surprisingly bright, which suggests a large number of stars may already have formed inside it. Another example is CERS-93316, another distant object that seems to challenge our expectations. These discoveries are still being studied carefully. Astronomers must confirm their distances and masses, because measuring objects so far away is extremely difficult. Even small errors in measurements can make galaxies appear older or younger than they really are. But if these observations continue to hold up, then something important may need to change in our understanding of cosmic history. Perhaps early galaxies were able to form stars much faster than we thought. Perhaps the conditions in the young universe were more favorable for rapid structure formation. Or perhaps our current cosmological models are missing some crucial piece of physics. Scientists are already working to update their simulations. They are testing new scenarios, adjusting parameters that control how gas cools, collapses, and forms stars. Because when observations challenge theory, science does not ignore the evidence. Instead, it adapts. It searches for better explanations. This is how scientific knowledge grows. Every strange discovery pushes us closer to the truth, and the galaxies discovered by jwst may be doing exactly that. They may be revealing that the early universe was not as simple as we once believed. Instead of slowly building galaxies over billions of years, the cosmos may have been capable of assembling enormous structures much faster. And if that's true, then somewhere in the depths of space, even more surprising galaxies may still be waiting to be discovered. What these discoveries mean for the universe. Every time astronomers discover something unexpected, it forces them to ask a deeper question. Are our theories incomplete? The strange galaxies observed by the James Webb Space Telescope may be one of those moments, because if galaxies truly formed earlier and faster than predicted, then our current picture of the early universe may only tell part of the story. For decades, scientists believed galaxy formation followed a slow and predictable path. Small structures formed first. Gravity gradually pulled matter together. Over billions of years, galaxies grew through mergers and accumulation. This idea is supported by the standard cosmological model that describes how the universe evolved after the Big Bang. But new observations are starting to push against that timeline. Instead of tiny, faint galaxies in the early universe, jwst is revealing objects that appear large, bright, and surprisingly mature. And the more astronomers observe the distant cosmos, the more examples they continue to find. This does not necessarily mean our theories are wrong, but it may mean they are incomplete. For example, early star formation may have been far more intense than we previously thought. Massive gas clouds might have collapsed much faster in the dense environment of the young universe. If those clouds formed stars rapidly, galaxies could have grown far quicker than current models predict. Another possibility involves dark matter, the invisible substance that makes up most of the matter in the universe. If dark matter clumped together faster in the early universe, it could have created gravitational wells earlier than expected. Those wells would attract gas more efficiently, allowing galaxies to form sooner. There is also the possibility that these galaxies are simply extreme outliers, rare objects that formed unusually early but do not represent the typical universe. In a cosmos containing hundreds of billions of galaxies, statistical anomalies are bound to exist. But if jwst continues to find more of them, then the anomaly may become the rule. And that would require scientists to rethink how galaxies grow. This is why astronomers are so excited about these discoveries. Not because they prove our theories wrong, but because they push science forward. They reveal gaps in our understanding. They highlight questions we didn't even know we needed to ask. And every new observation from jwst adds another piece to the puzzle. A puzzle that describes how the universe evolved from a hot, dense beginning into the vast cosmic web we see today. Somewhere within those distant galaxies lies the story of how structure first appeared in the cosmos, how stars ignited, how matter gathered, and how the first great cities of stars were built. And as we continue exploring the deepest regions of space, we may discover that the universe was capable of creating complexity far earlier than we ever imagined. The future of this cosmic mystery. The discovery of galaxies that appear too early in the history of the universe is not the end of the story. In fact, it is only the beginning, because astronomy works slowly and carefully. Every surprising discovery must be tested again and again. Distances must be confirmed. Mass estimates must be verified. Observations must be repeated using different instruments. Right now, astronomers around the world are studying these strange galaxies in detail. They are analyzing their light spectra, which reveals information about their age, chemical composition, and distance. Spectroscopy allows scientists to measure something called redshift, which tells us how far away an object is and how far back in time we are seeing it. If these measurements confirm that the galaxies truly formed only a few 100 million years after the Big Bang, then they may represent some of the earliest cosmic structures ever observed. But the story does not stop there. The James Webb Space Telescope is still in the early stages of its mission. It will continue scanning the universe for years. Each new observation will reveal more galaxies from the distant past. Some may turn out to be smaller and more primitive, confirming parts of our existing theories. Others may be just as mysterious as the galaxies already discovered. And if astronomers find even more massive galaxies at extremely early times, then our understanding of cosmic history may need to evolve. Future telescopes will also help solve this mystery. Ground-based observatories, such as the Extremely Large Telescope, will be able to study distant galaxies in unprecedented detail. These telescopes will measure star formation rates, galaxy structure, and chemical composition with far greater precision. Together with jwst, they will help answer some of the most important questions in cosmology. How quickly did galaxies form? How rapidly did stars appear in the early universe? And how did the first cosmic structures grow from simple gas clouds into massive galaxies? These questions are not just about distant objects. They are about our own cosmic origins, because the Milky Way was once a young galaxy too. Billions of years ago, it began as a much smaller system of stars and gas. Over time, it merged with other galaxies, forming the vast spiral structure we see today. Understanding how the first galaxies formed helps us understand how our own galaxy came to exist, and ultimately, how the environment that allowed planets and life to emerge was created. So the mysterious galaxy that seemed to appear too early may be more than just a strange observation. It may be a clue about how the universe built its first structures, a clue about how quickly cosmic evolution began, and perhaps a reminder that even after centuries of studying the cosmos, the universe still has many secrets left to reveal. Looking deeper into the past, every powerful telescope humanity builds allows us to look a little further back in time. And every time we look deeper, the universe reveals something new. For decades, astronomers believed they had a good understanding of how the early universe evolved after the Big Bang. First came the formation of atoms, then the long cosmic dark ages. After that, the first stars ignited. Small galaxies slowly began forming. And over billions of years, the vast cosmic structures we see today emerged. But the discoveries made by the James Webb Space Telescope suggest the story might be more complicated. Instead of a slow and steady beginning, the early universe may have been far more active than we imagined. Gas may have collapsed into stars faster. Galaxies may have assembled earlier. And the first cosmic structures may have appeared long before scientists expected them. If this is true, it means we are only beginning to understand how quickly the universe became complex. It also means that the earliest chapters of cosmic history may still be largely unknown, because the galaxies jwst is discovering are only the beginning. There are likely many more waiting to be found. Objects even farther away. Galaxies that formed even closer to the moment when the first stars appeared. And somewhere among them may lie the true origins of cosmic structure. Future observations will continue to push the limits of what we can see. New instruments will measure distant galaxies with greater precision. Astronomers will refine their models and simulations. And with every discovery, we will move closer to understanding how the universe built its first galaxies. because the strange galaxy that seemed to appear too early may not be an exception. It may be a clue that the early universe was capable of far more than we once believed, a universe that began forming stars, galaxies, and cosmic structures much sooner than anyone predicted. And if that is the case, then the cosmos may still be hiding many more surprises in the deep darkness of space. The galaxy that changed our perspective. The universe is vast. So vast that even our most powerful telescopes can only observe a tiny fraction of it. And yet, within that small window of observation, discoveries continue to reshape our understanding of reality. The mysterious galaxies discovered in the distant universe are a perfect example. For decades, scientists believed they understood how galaxies formed after the Big Bang. Small structures would appear first. Stars would slowly ignite inside clouds of gas. Gravity would gradually pull matter together, and only after hundreds of millions or even billions of years would large galaxies emerge. But the discoveries made by the James Webb Space Telescope suggest the universe may have been capable of building complex structures much earlier than expected. Galaxies appearing when the universe was still extremely young. Galaxies that may contain billions of stars only a few 100 million years after the Big Bang. If these observations continue to be confirmed, they may change how scientists think about the early universe, not because they completely overturn modern cosmology, but because they reveal that the universe may have evolved faster and more dynamically than we imagined. And that is one of the most exciting things about science. Every discovery leads to new questions. Every observation opens new mysteries. The universe is not a finished story. It is an ongoing exploration, a puzzle that humanity is still learning to solve. And the deeper we look into space, the more we realize how much there is left to discover. Because somewhere out there, far beyond our galaxy, there may be even older galaxies waiting to be found, structures that formed even closer to the beginning of cosmic time. And each one will bring us one step closer to understanding how the universe itself came to be. What came before the first galaxies, long before the first galaxies appeared, before stars filled the universe with light. The cosmos was a very different place. Right after the Big Bang, the universe was extremely hot and dense. Matter and energy were mixed together in a chaotic plasma. Particles collided constantly. Photons could not travel freely. The universe was opaque. But as space expanded, everything began to cool. After about 380,000 years, something important happened. Electrons combined with protons to form neutral hydrogen atoms. For the first time, light was able to travel freely through space. That ancient light still exists today. Astronomers call it the cosmic microwave background. It is essentially the oldest light we can observe. A faint glow spread across the entire universe. A snapshot of the cosmos when it was still incredibly young. But after this moment, the universe entered a long period of darkness. Astronomers call it the cosmic dark ages. During this era, there were no stars yet, no galaxies, just vast clouds of hydrogen and helium filling space. Gravity, however, was already at work. Tiny fluctuations in matter density began to grow. Some regions contained slightly more matter than others. These small differences were extremely important, because gravity amplified them over time. Slowly, matter began to collapse into larger clumps. Invisible halos of dark matter formed first. These halos acted like gravitational traps. Gas began falling into them. As the gas became denser, temperatures increased. Eventually, pressure and gravity reached a critical balance, and the first stars ignited. This moment marked the end of the cosmic dark ages. The universe, which had been silent and dark for millions of years, suddenly began producing light. These first stars were powerful, far larger and hotter than most stars we see today. Their intense radiation transformed the surrounding universe. Hydrogen gas that had once been neutral became ionized again. Light spread across space, and slowly, small clusters of stars began forming the earliest galaxies. But even then, galaxy formation should have been slow. At first, these galaxies were expected to be tiny, small structures containing only a few million stars. Over time, they would merge and grow larger, eventually forming the massive galaxies we see today. But discoveries made by the James Webb Space Telescope suggest something unexpected. Some galaxies in the early universe appear far more massive than they should be. They appear bright, structured, and surprisingly mature, as if they had already gone through long periods of growth, which should have been impossible so soon after the first stars appeared. This is what makes them so mysterious. They seem to appear almost suddenly in cosmic history, almost as if galaxy formation accelerated dramatically during the universe's earliest moments. And if that is true, then the story of the first galaxies may be far more complex than scientists once believed. Instead of a slow transition from darkness to structure, the early universe may have experienced bursts of rapid creation, moments when enormous regions of gas collapsed quickly, stars ignited in massive numbers, and galaxies formed far earlier than expected. If future observations confirm this possibility, it could change how we understand the earliest era of cosmic history, because the universe may not have waited billions of years to build its first great structures. It may have begun constructing them almost immediately after the first stars appeared. And somewhere out there, hidden in the deepest regions of space, even older galaxies may still be waiting to be discovered. What if we're seeing the universe too early? When astronomers observe distant galaxies, they are not just seeing objects in space, they are looking back in time. Because light travels at a finite speed, every distant object shows us a moment from the past. A galaxy 1 billion light-years away appears as it was 1 billion years ago. But when we observe the most distant galaxies discovered by the James Webb Space Telescope, we are looking even further back. Some of these galaxies appear only 300 to 500 million years after the Big Bang. That is extremely early in cosmic history. So early that many scientists expected to see only the smallest and simplest galaxies. Instead, the universe is showing us something much more complex. Galaxies that appear bright. Galaxies that may already contain billions of stars. Galaxies that look more developed than expected. But this raises another possibility. What if we are misinterpreting what we see? The early universe was very different from the universe today. Gas was denser. Star formation may have been far more intense, and the first generations of stars were probably much larger and brighter than modern stars. If a galaxy contains many of these extremely luminous stars, it could appear far brighter than its actual mass would suggest. In other words, the galaxy might look bigger than it really is. Astronomers are currently investigating this possibility. By studying the light coming from these galaxies in detail, scientists can estimate how many stars they contain and how old those stars are. This technique, known as spectral analysis, helps researchers determine whether these galaxies truly contain enormous numbers of stars, or if their brightness is being amplified by young, powerful stellar populations. There's also another challenge when observing objects so far away. Distance measurements are extremely difficult. Even a small uncertainty in redshift calculations can significantly change our interpretation of a galaxy's age and size. Some galaxies that initially appeared extremely massive have later turned out to be slightly closer than first estimated. If that happens, the galaxy would not be quite as old as it first seemed. But even with these corrections, the early universe still appears more complex than expected. The number of bright galaxies being discovered continues to surprise astronomers. Each new observation forces scientists to refine their models, to adjust their simulations, and to explore new explanations for how galaxies could form so quickly. Because even if some galaxies turn out to be smaller than first believed, others still appear too massive to fit comfortably within existing theories. And this is what makes the situation so fascinating. We may be witnessing the moment when new observations begin reshaping our understanding of the universe, not by destroying existing theories, but by expanding them, adding new pieces to the puzzle. The early universe may have been a place of intense activity, a time when matter collapsed rapidly, stars formed in enormous numbers, and galaxies emerged faster than we ever imagined. And as telescopes continue to peer deeper into space, we may soon discover whether these strange galaxies are rare exceptions, or the first signs that the universe grew up much faster than anyone expected.